Hey, what's up? Rob here, and this is a follow-on video for the PowerFet Booster Pack. I just put up a blog post about that. The design's finished, and I did some pulse width modulation examples to show kind of how that worked and why you'd use it. So this is a follow-on video to show some application. I actually had an application where I wanted to install under-cabinet lighting in my kitchen. I wanted to use really bright LEDs. Or a little more powerful than what you'd find at normal stores. So I designed this power controller for the launchpad as a cheap, low-cost solution using a platform that's already developed from Texas Instruments, and it's basically just a booster pack you plug in. And so we'll get into the details of this a little bit later in the video, but as an introduction I wanted you to see the overall kitchen and the cabinet layout, and so then we'll go into kind of how I did it, and to see how it works, go back to the previous post. It will be linked under this video, and I did a write-up as well under the video to show how this worked and how you use it in some more advanced applications. This is pretty simple. I'm just turning on some 12-volt LED strips, and so it's not too much to it, but I did want to show you there is some real-world application here, and it's a cheap solution for under-cabinet lighting. And at the end of the video I'll talk a little bit about design requests. Since I'm a designer, you may want your own controller for this, so you can get in touch with me and we could work on that. But this is the layout. I've got cabinets going across my kitchen, and I wanted to put under cabinet lighting on this side and over here on this side. And so I did, and this is what it looks like when it's powered up. You see the kitchen's kind of dark, and so this helps a lot to brighten it up. So once you turn these on, it's the full length of the cabinet. There's two LED strips. One of them's cut up into thirds, and then one of them is just a complete strip with no modifications. And they all run up to the controller in the cabinet above the microwave up here. And so this is what it looks like from a little more abstract point of view. You can see the whole setup and the whole cabinet display. And so we'll get into some more details now. Alright, so now we've got a little closer view. You can kind of see a little better the lights and the kitchen layout. And so the basic way this is laid out is there's a switch, just a switch tied to the digital I/O here that turns it on and off. I guess I should preface this by saying that this is more geared towards people who are familiar with electronics and embedded electronics, embedded processors and stuff like that. If you're not into electronics, we'll go over some solutions a little bit later in the video, but those of you who are technically savvy and are aware of some basic embedded systems, this is all based on the launchpad from Texas Instruments. It's their Value Line Series evaluation board for their Value Line Series processors, and it's really simple. It's really cheap. That's why I developed this booster pack around it, because it's a great experimental learning tool, and it's great. In application too. As you can see, this thing for $5 is my digital controller running this, so it's really cheap. They're really easy to get, and they're really easy to work with. And so those of you who are familiar with it and have seen the previous video, this is a booster pack I designed that's basically a motor controller. It's got digital I/O tied to a PowerFet, digital I/O pins that support pulse width modulation tied to the second PowerFet, and then it's got the I2C communication bus, and all of those are brought out to locking headers, so you can build a little wiring harness and just plug them in, which is what I did for this. And so I have some detailed screenshots of the controller, power supply, and all these subsystems that we're going to talk about down in my write-up, so check those out if you need a visual aid right now. But to get back on track, the way this is kind of laid out, the button is here to turn them on and off. Since you're at the sink most of the time, that was the best place to put it. And it controlled two power strips. One I cut into thirds, so you've got little light arrays under each cabinet door, and then the whole strip is over there, unmodified. It's just one complete strip, and it's just a flex strip with LEDs on it. But I got them from Super Bright LEDs. They're really powerful. I think they're the most powerful strips they have, and I got them to be powerful because I have a kitchen that's particularly dark because there's accent and colored lighting, and so I wanted the cabinets to be illuminated with a little more light than normal, and these are substantially more powerful than you find in stores, that sell home products like this. So the way this is laid out is you've got your button that turns them on and off right here. That's tied to the switch or the push button on the launch pad. Is basically just extended. So this button is tied into digital I/O on the launch pad. I think it's switch 2, and so there's not too much modification there other than it's just been extended. And then each light strip is tied into each of the headers that are connected to the PowerFet on the PowerFet booster pack. And in the cabinet above the microwave, I've got the controller, aka launchpad, with the PowerFet booster pack plugged in on top and the power supply, and that's it. So the subsystems of this overall lighting system are really just 4 parts. There's the lights, the launch pad, the PowerFet booster pack, and the power supply. And so just to mention a few words about each one, these light strips are 12 volt at 1/2 amp each, and so they're pretty powerful. As you can see, in real life they're even more powerful than you can probably tell on the video. The launch pad is just a typical launch pad, TI developed. You can buy on any distributor, DigiKey, Mauser, and so there's nothing fancy about that other than I basically extended the push button out to my sink so I could tell the system to turn on and turn off. The booster pack is something I designed and developed. It's on my website. There's a video blog and a write-up about it on my tech blog, so go check that out. That'll be linked under the video, and there's a demonstration of a little more advanced application with pulse width modulation and increasing the pulse width over time, and you can see that on the O-scope. And the last part is the power supply. I've got a 12 volt 4 amp supply. You don't need 4 amps, but you need to gauge this to a decent amount above your maximum load, and so my maximum load is only about 1 amp. I just got the 4 amp supply because I did some development, some R&D, and I wanted to have a little bit more power than just 1 amp at 12 volts. So that's pretty much the whole system. The greatest thing about this and why I did this, ignoring development costs, which really weren't all that much, this system was pretty cheap. It cost about $70 to get this, as opposed to about $70 per light, which is what I saw in a lot of home improvement stores. You've got the power supply, which is $25. You've got the launch pad, which is $5. The booster pack is about $10, $12 once I get it up for sale. And it'll be as a kit, so you will have to assemble it. But that's still pretty cheap for a power controller, load controller. And the LED strips were about $15 a piece. I got those from Super Bright LEDs. I got the power supply from there too. It's just a standard plug-in AC to DC power adapter, and you plug it in your wall. It outputs 12 volts at 4 amps, and that plugs into a barrel connector on my booster pack, and that power is just switched on to the LED strips. So it's pretty simple, especially if you're familiar with this stuff. It's really cheap. You could expand this to quite a bit more accent lighting, more under cabinet lighting for $15 a strip once you have the controlling the power supply, and you just build your own cable harness. As you can see in the last video, the booster pack has locking headers, so you can plug those in and they're not going to pop out. They're pretty strong. So for those of you who aren't real familiar with electronics, the embedded world, embedded C, embedded processors, electronics, software and hardware development, this isn't the greatest off-the-shelf solution. It may be a little hard to use, so I wouldn't necessarily recommend this to someone who's not familiar with, if you're not familiar with the launch pad, this may not be a great idea to get into. But if you are, it really is a great solution for more than just LED strips and whatnot. You can control, it's a power delivery controller is what the booster pack is, and it's a really cheap solution. And the other aspect of this is if you're in the lighting industry, if you're in the home improvement lighting industry, or any kind of kitchen accent lighting or accent lighting in general, it's kind of a proof of concept of a real cheap solution, because this whole system's just based on the embedded processors from TI that this launch pad is developed around. So if you are in that industry, get in touch with me, because for me it's really cheap to design and develop these R&D devices, and I could develop a custom controller with whatever functionality that you'd require for a pretty low price point. I mean, R&D in the 100 to 200 to 300 bucks is pretty low, so you don't have to make a giant capital expenditure. There's a lot of opportunity to take advantage of the low power features that Texas Instruments offers, and there's a lot of opportunity to take advantage of more unique ways of delivering power. And so for example, this system actually powers off. It's got a timer, so it powers off after 90 minutes. You can't forget it's on. And so it's a really good solution. It's low cost. If you're in the industry and you're interested in developing, get in touch with me through my website. I've got a contact form. Send me an email, and I'd love to talk with you some more. If you are just looking to purchase a lighting system, you're not familiar with electronics, also feel free to get in touch with me. I'd love to talk to anybody out there about this. I think this is a pretty good proof of concept. The PowerFet Booster Pack is a lot of fun, and so this is an example of some real world application that I had. It works out really well. It really makes a big difference, and the freedom to use whatever LED strips that you want and whatever lighting loads that you want is really nice, because you can kind of tailor this to fit your needs and use the lighting products that you like, more so than having to just pick from a couple. So feel free to get in touch with me if you're in the industry. I'd love to talk with you more about it. And it's a great system. Thanks for watching my videos. Feel free to comment and check out the rest of my text blog.